Hello. Hi, Ben. Hope you're doing well today. It's such an honor for me to be moderating this session. I'm Ruam, by the way. I'm currently head of digital asset at SCBX. We are the largest financial group in Thailand, and we are also the holding company for Siam Commercial Bank, the largest and the oldest bank in Thailand, as well as the holding company for SCB 10X, our organizer for Redefine Tomorrow 2026. Such an honor to be here, and I think we should just let's get into the session. For the first question, could you introduce yourself and Gensyn a little bit for our audience today? And just, based on where you are at for 2026, what changed in this year that makes the compute layer for on-chain intelligence a board level decision rather than just an innovation side topic?
Yeah, sure. Great to be here. Thank you for having me. I'm Ben, as you mentioned, co-founder and CEO of Gensyn. Gensyn is the network for machine intelligence. So we build infrastructure for machine learning to be done on any device in the world by anybody, completely kind of open, and then connected up to a blockchain for decentralized trust, essentially. So that means you can connect it to financial workflows, but you can also create markets and things like that over the resources that are required for machine learning. You can think about it as the next sort of iteration of open source in an area where open source isn't quite good enough. You can go kind of open source on the code required for machine learning, but then there are a ton of resources like GPUs and data that are required as well. And we don't really have an equivalent of open source right now for those resources. They can be very expensive. They can't be offered for free, but we could have free markets over them and sort of permission to access via kind of permissionless and untrusted or trustworthy methods. And that's what we build with the Gensyn network, essentially. I guess to your question, what changed in 2026? To be honest, I think for us and for other decentralized AI projects, there's probably a realization of what decentralized AI needs to do. There's a lot of promise for what you can do with decentralized infrastructure. Probably one of the biggest things that any team will promise is the scale that you get from accessing decentralized resources. So we look at how AI is trained right now, and it's trained in these huge data centers by a single company, and then that company is able to kind of make money from those models. We had a wave of open source models that were created in the past few years, but that wave is sort of closing. Those large companies are realizing that they don't necessarily make back all of the money that they invested in training an open source model. And so it leaves this kind of gap for everybody else where if you want to use AI or machine learning, you're either forced to go and use one of those companies' products and you can't kind of build alongside it, or you're forced to try and raise billions of dollars to train a model for yourself. And there's this sort of gap down the middle where models could be created out in the open on everybody's hardware, but the research and the technology isn't quite there yet. And I think we all the companies like Gensyn, we sprinted towards getting to the stage where we could train like a foundation model across commodity hardware. The idea being like everybody connects their MacBooks up and kind of GPUs and things like that. You get this network of millions of devices, and then you train a model that rivals Llama 4 or rivals ChatGPT's newest model or something. That is definitely possible in the long term, but it's still not there yet. And it's still, to be honest, reasonably far away. Like it's not going to happen this year, and it's who knows about next year. But still, I think decentralized AI had this moment where it realized it can't just keep promising that anymore. It needs to prove what's viable over infrastructure today. And that brings us to my kind of answer to this question: what changed in 2026? I think our attitudes as companies. And so Gensyn's attitude changed from can we sprint towards training this huge model over commodity hardware to what can we do right now today on a decentralized AI network that you cannot do elsewhere? And that's what brought us to our flagship app, which exists on our mainnet right now. So our mainnet went live a few weeks ago. It's a layer 2 on Ethereum, the Gensyn network. And we have a flagship app on there called Delphi. And Delphi allows anybody in the world to create an information market, which is very similar to a prediction market. But the idea is when they create that market, the settlement of the market, so the decision about how that kind of market ends, is made by an AI model, which is completely proven and verified on chain. And that just isn't possible in any other kind of arena. It's not possible any other way. And it unlocks this kind of basically new genre of finance where individuals are able to pay for information by creating markets and seeding them with liquidity. And they're also able to sell information by trading in these markets as well. And so there's suddenly this new bi-directional trade of information that exists that just could not exist before. The closest possible thing you have is like Polymarket or Kalshi, but they don't let you create markets, and they can't let you create markets because they have no way of reliably settling those markets. And that's what this AI oracle that's connected on chain and verified and auditable and kind of provable can actually do. And it can do it today. It's not a promise for 5 years in the future. It's something that exists right now. And I think that, to go back to the question again, that's what changed for us, was realizing we have to build something that works today, that takes advantage of decentralized infrastructure, not something that's just a promise for 5 years in the future. We'll still build that, but it's not enough. You've got to prove something right now. And that's what I think the crypto market needs. It needs proof of real value rather than promises.
That's super interesting. And I understand that you guys also do look a lot of work look into the authorization problems. So where do institutions still misdiagnose the problem around agent authorization boundaries, and what does that mistake cause in production?
So we sit quite low down the stack. We mostly focus on infrastructure, and so when it comes to authorization and things like that, it's very much an application level problem. Our belief is, as agents start making more and more decisions, when those decisions involve more than two parties, you have a trust problem. And no matter how you kind of what like checks you put in place for the agent's behavior, you're still going to have a trust problem amongst the people who care about the system. And so you have to solve that somehow. And that's what this verifiable, auditable machine learning provides you. It provides you a way to take that kind of agent's brain and execute it somewhere that everybody involved can trust. It's basically exactly the same concept as Ethereum. So with Ethereum, we're able to execute a small computation, and everybody involved can trust that that computation was done correctly. You never kind of worry that the execution or the kind of set of steps required to transfer Ethereum from me to you, like neither of us worry that that's going to execute properly. We just know it will do because that's the entire point of Ethereum. But that doesn't exist for agent operations right now. Like if you and I wanted to kind of execute an agent together for some reason, one of us would have to do it and the other would have to trust that person. So there's this gap where we can't both enter this situation without having some way to trust each other. And so you could view this as expanding what Ethereum gave us to kind of agents and to AI, or you can view it as bringing a level of kind of like trust, kind of a trust solution that is much lower cost than whatever would currently exist. Like if you and I needed to trust each other on an AI execution right now, we'd probably have to write some kind of contract between us, and then we both sign it, and then I don't know, maybe one of us would sue each other or something. Like it's a really horrible, expensive way of actually solving that trust problem. So I went a little bit away from the question there, but I think when it comes to any kind of authorization of agent actions, if you need to establish trust, you're going to need some kind of oracle like this. I guess to go a little bit away from what Gensyn does and more into just like the machine learning space and a bit like maybe how I think about this, but I think we're going to see an expansion and contraction of what people allow agents to do. I think OpenClaw was like the kind of max expansion where a bunch of people just installed this thing on their kind of home PCs. They let it have absolutely every permission possible, and then they just sort of sat back and used it and said, "Hey, this is really cool." And sure, that is cool, but that leads to some pretty significant exploits and problems. And I think what we'll see is more and more of those exploits and problems happen. The world will sort of contract back and say, "Oh dear, like this has caused some like severe problems. We need to think about permission boundaries, etc." We'll probably go a little bit too far in locking things down. And then there'll be another expansion again where somebody says, "Hey, if you give an agent a bunch of permissions, it can do something even cooler now." And then everyone kind of gets excited again. So I think there's going to be this sort of like expansion, contraction, like pendulum between just giving it as much authorization as possible to see what's possible and locking it down so that it doesn't affect you severely and like exploits happen, etc. And I think that's inevitable because like it follows like the human excitement curve. Like that's how we work. And I think crypto as a sort of space is very, very familiar with this. Basically, every single cycle in crypto involves mass excitement about a technology until that technology doesn't really fulfill all of the promises immediately. Like we saw this with ZK, we've seen it with AI. What you typically see, though, is that mass excitement and then the contraction where everyone says, oh, that technology was a scam. It didn't work. We all got excited over nothing. And then quietly, the technology proves itself. And then suddenly everyone realizes that we're just using it now. We don't need to be super excited about it. It's just really good and it works in all of our technologies. I think you'll see the same thing here. Massive excitement, over adoption, contraction back down when people get scared, and then gradually just like mass adoption again. But kind of quietly, people just don't even think about it anymore. It's just there.
Thank you for that. Yeah, that's definitely super exciting. There's definitely the vibe or like the feelings that people have, right? And I think just now I think you mentioned a little bit about exploits, and I think that also reminds me like very important things around safeguards, but maybe a little bit of it from a different angle. So, like for example, before scaling, what would you say is like the first non-negotiable design decision that you would look for in terms of transaction signing safeguards?
Um, I guess when it comes to transactions, yeah, I guess when it comes to like agents or AI making these decisions, um, it's hard to answer this question because there's what should happen in the long term, and then there's what needs to happen right now, just so that everybody realizes what's possible. And that's that like expansion contraction thing. And I think you can go too far at the beginning by second guessing what you need to do. And in doing that, you actually never reveal what's possible. And so a kind of good example of this is in the early days of Gensyn, we focused really, really, really heavily on verifying exactly what was happening with an AI model. And that's really valuable now. We use it for the AI Oracle, like it solves a bunch of use cases really, really clearly. But actually, the original reason we were building it was to build a compute network. It was just to allow people to connect up their GPUs and allow somebody else to use their GPUs. And with hindsight, we went too far on the security angle. We didn't need to build that level of verification for that problem at that time. It happens to be something very, very valuable in the long term. So, like, it's really good that we built it. But for the original problem we built it for, actually, if I was to approach that today, I would approach it differently. I wouldn't build this level of kind of hardcore verification. I wouldn't sort of look into the future and say all of these kind of secure things are required in the very long term. I would just say, let's solve the problem now. Let's accept that it's going to be somewhat insecure, and we tell people that and make sure people don't use it for like the kind of end state workflows. They just use it for some intermediate workflows, but at least you get feedback and at least you get people to realize what's possible. And so I think the same thing is true here. The design decisions I would make specifically would skew towards allowing a certain degree of kind of risk basically on what happens. Like you're going to have to take that risk. There are going to be some exploits. There are going to be some transactions that happen that maybe shouldn't have happened. If we're talking about like AI agents making transactions, for example, but I think that's better than going too far the other way, locking it down and actually never revealing what is possible because you've locked it down prematurely and you never realize what the risks were. The same thing, it's basically the same principle of just testing kind of boundaries. If you never test a boundary, you never actually know where that boundary is. You can assume where it is, but you don't know. And so in order to test a boundary, unfortunately, you have to kind of fail. You have to have a negative outcome to actually know that you've breached the boundary. And I think this is the case here. So I've kind of avoided your question a little bit by saying that we should take risks. That said, non-negotiable things, I think you have to trust, and I'm going to sound like a broken record, but I think you have to trust the AI model that is making a decision. If you're doing like an agentic transaction of some kind, I think you have to know fundamentally how it's made the decision that it's making, because then you can go back and look at it. You don't necessarily stop the decision from happening. You don't stop the transaction from being signed, but you at least have an audit trail so you can go back and look and know why it made that decision and fix it for the future. So it's more about information gathering than it is kind of stopping things from happening. But it totally depends on your workflow. That makes sense if you're doing like consumer transactions below a certain size and everybody is aware and willing to engage with the system, knowing that there's going to be some degree of loss or risk here. It obviously doesn't make sense if you're making like $100 million transactions and you need like perfect security. In that case, you do a kind of much more robust system. So yeah, TLDR, I think we should take more risk. I think in the past, Gensyn has tried to build for that like end state that we know will exist, but we don't know when. And in doing that, we've actually missed proving the kind of intermediate steps. And I think we should do that here. We should prove the intermediate steps, accept a level of risk, and then build for what we realize now is the kind of risk.
Yeah, and like just following up on that kind of tone between like just like taking a little bit of the risk, like or like even going a little bit deeper on automation, like versus like on the human judgment or human like oversight, like I get that feeling a little bit. So just like want to ask you about like the trade-off. So for example, between automation depth and like human oversight requirement, to you, which side, comes first or wins first, and what threshold would tell you or like you should inform like users to switch? Yeah.
Mm. Yeah, I think the world's still figuring out how much we are going to outsource to AI, like in terms of decision making, in terms of oversight itself, etc. I think OpenClaw was a moment for a lot of people where they realized that the world is more willing to outsource huge amounts of that than maybe we thought before. One of the and this is a bit of an aside, but one of the interesting things about like the OpenClaw wave was that that concept had existed for a while. Like OpenAI had their operator, like the idea of computer use agents had existed for ages. I think Anthropic had something somewhat equivalent. None of them had taken off, and the reason they hadn't taken off probably is that they took a kind of gradual permissioned based approach where they said this thing can exist and it can use your computer and it can make all these decisions and it can do things on its own. But every time it comes to a decision that it hasn't really come to before, you're going to have to give it permission to do that. And so you're going to have to sit in front of it and you're going to have to okay every single step. And basically, what that meant was that people just didn't do it. It wasn't that people kind of gradually gave it those permissions and they let it run wild. They actually just never got there because the fatigue of giving it the permissions just meant that they just gave up and they were like, oh, this just isn't very good. This like system doesn't work. Thing is, the system did work. It was just a permissions issue. And you have to work around this kind of issue with humans that we have really, really short attention spans and we have like limited energy for doing repetitive tasks. And giving an agent those permissions was like just a really, really repetitive task. And so then OpenClaw came along and said basically the exact opposite. It was like instead of the agent having no permissions and you having to give it each one, the agent has all of the permissions and you have to take them away if you think it shouldn't have them. And so I think when people ran that, they could see what was actually possible. And they could see what the kind of agent at full sort of full capacity could actually do. And then suddenly everyone was really, really excited about it. But it was kind of the same thing that we had before. We just like approached it differently. And the only difference was in the agent, like the authorization and human oversight part. So I think realistically, the entire world hasn't really figured out what level of human oversight is going to be required to allow these things to operate. There's something I like to talk about, which is I think you can categorize machine learning in an interesting way. And I categorize it down like three angles. There's automation, this idea that or autonomy, this idea that we'll kind of create these agents, we'll send them off into an environment and they'll have like free reign of the environment, basically. And then maybe I give them a set of instructions and I say, hey, achieve this goal. And then it just goes off and it does whatever it needs to do to achieve that goal. That's like one class of AI. The second class is augmentation. And this is the idea where rather than me sending off a model out into an environment to do all those tasks, actually it just like sits alongside me and just makes my life better. And I actually think that that second class, that augmentation class, is going to be a lot larger than the autonomy class as a technology. The autonomy class is interesting to us because it like hasn't existed before, and it sort of scratches that itch of like having a totally new intelligence that's like another being. We like anthropomorphize it. We think about it as like a kind of pseudo human, and it can like think on its own and things like that. Like it's kind of exciting to us because it's another being. But I actually think it's much more powerful when it's in the augmentation kind of arena where it's actually just the software we use. It just becomes slightly more intelligent. And I don't need to think about it as another being. Maybe it's just like it's my web browser, it's my coding IDE, it's the word processor I use to write documents. Like it's just got better. And it doesn't need to be personified. I don't need to think about it as like another person and like talk to it or anything like that. I just need to interact with it as a piece of software. And it's as if my word processor just got 1,000 times better. Like it's kind of the autocorrect is better, the next word prediction is better, like it can format my documents better, etc. But I'm not chatting to it, I'm just using it, and it's just better software. And I think that that's a really underserved kind of class, and I think it's actually quietly going to be the biggest use of AI by far. The third class, incidentally, is like ambient AI. This is the sort of like AI as a technology that just exists around us and we don't even know about it. Great example are like fitness trackers, Apple Watch, etc. These things where, hey, it can detect if I fall and it can call emergency services. And actually, I never interact with it. Like I don't even know it's there, but it helps me by kind of sensing my environment and making decisions that will assist me in some way. And I think there'll be a bunch of that as well. And that's all in wearables and devices and things. And it's another sort of like more hardware focused pervasive version of AI. But yeah, I think realistically, we've all got really excited about autonomy. I think that's because as humans, we like the idea of intelligent beings themselves. But I think that's probably, in my view, the smallest of the three classes of AI in the future. The others will be much, much bigger. And they don't really, like human oversight kind of disappears with them because I'm just like using the software. So my oversight is my use of the software. Again, I've not really answered your question. I've just avoided it. But broadly, I think the oversight point, it becomes important when you're looking at autonomy. I think the world needs to learn it rather than guess it ahead of time. Learning it, like I said before, will lead to risk and like poor outcomes. But that's just kind of the way you build a technology. Maybe the final anecdote I would give is thinking about how good humans are at oversight. TLDR, not good. We're really bad at it. A great example of this is when you look at some of the early experiments with radiographers and having AI systems label images for them. So we went through a few phases of this. At first, there was this big panic where radiographers were going to disappear. We wouldn't need them anymore. And the AI would just do everything. And then that obviously wasn't true. And actually what we got were tools for radiographers to do their job better. And that was really cool because it was basically we moved from that like autonomy world where we were like, oh, we're just going to replace them to actually know it's augmentation. We're just going to like give them better tools. But when we moved into that augmentation world, we then realized another problem, which is that if you use the AI to make the decision and then just have the human check the decision, after a certain amount of time, humans will just okay everything because we just assume that it's correct all of the time. If it's correct like 99% of the time, basically a human stops checking because there's something in our brains which basically says it's not worth me doing this. This thing is correct enough that I'll just okay everything. And basically you never actually catch anything with a human because they're just like okaying everything because they trust the AI more than they trust themselves. Like they're just like going along with the system. But you can change the way that the human interacts away from the AI has made this decision. Do you agree with it? To the AI has labeled these things. Now you need to make a decision. So you have to make sure that the human is still making a decision. It can't just be okaying or kind of checking a decision. And I think that's where basically like two things happen. One, you have to sort of gamify human oversight. You have to make it part of the kind of humans' actions themselves. And two, in doing that, what you're doing is actually moving from autonomy to augmentation. You're just saying the software is better now, but you're still making the decision as a human. And so it's not really oversight anymore. It's actually just making the human better.
Yeah, Ben, you and Gensyn definitely sits at this very exciting space. There's this the intersection between blockchain and AI, and I think like probably the space have changed quite a bit over the past few years, like how do you think or feel about that? And also, are there any challenges or misconceptions that people may have, as well as, over the next like 3 to 6 months, what excites you the most about being in this space?
Sure. Yeah, lots of learnings, lots and lots of learning. So Jensen's been going for 7 years now. We've been building a lot of infrastructure. Like I said before, I think in the early days we solved a lot of problems that didn't exist yet, and we were probably too hasty to solve some of those problems. Like we were looking very far into the future and solving problems that we knew would exist, but were probably like 3 steps removed from the problems the world currently had. And I think that's like it's a it's a difficult thing because you end up with a bunch of solutions that you know are valuable, but you don't get that near term kind of proof of what you're doing. And so it's hard to prove to the rest of the world that what you've done is the right thing to do because you're still solving problems that don't exist yet. And you have to just keep telling people you will have this problem. And then when you're proven right, people like some people do recognize it, but they recognize it probably less than you would imagine if you when you start at the beginning. So one of the learnings is you have to prove the kind of milestones along the way. You can't just solve the long-term problems that you know will exist in the future in absence of kind of progress, because you won't be able to communicate it to everybody else. Like they need to see like tangible proof, basically. So that was one big learning. I think the second big learning was um, the way that AI presents itself to the world and like evolves across the world is basically it's unknown by anyone. It's massively uncertain. And you can see this in just like the AI world itself. Like there's continually bets made that don't pay off and then unexpected bets that do pay off. And it's clear from every company that's involved in AI, the hyperscalers, down to like a new startup. Everybody is in exploration mode and nobody actually knows what's going to happen because the way humans adopt a new technology is strange. Like it's just not predictable. And so I think that a big learning for us there was we could path out the kind of what's required on the infrastructure front in the long term, but we didn't know what order that would happen in. And actually, being able to build in the same order as technology is sort of progressing across the world is very valuable because it gives you the proof points, it gives you the ability to show progress, etc. Like I mentioned before, and so what we realize now is you can build for the long term, but you need to, as the kind of AI world develops, you need to sort of quickly move into each of those modalities and prove what's possible. And we've got better at doing this. A good example is last year, like when we launched RL Swarm over our infrastructure. And RL Swarm was basically a very, very large scale collaborative post training system. And it was when post training as a kind of approach was it was in its early days as being proven. Like people were starting to do post training. We'd seen with DeepSeek R1, etc., that it was really powerful. There wasn't a huge amount of it yet. But what we did was take our network and our technology and immediately deploy a post-training system over it, and it showed that actually decentralized AI is like really good for post-training here. We should have done more of that earlier. Basically, is a big learning for Gensyn to show that along the way of machine learning developing, our infrastructure was continually good for it, rather than pushing all the way to this end state where we could do everything. And I think it's a classic trap for like a deep tech founder is to just try and solve the like huge problem that exists at the end, but in reality, it's actually very hard to continue to exist long enough to prove that. So yeah, big learning there. I think in the next 3 to 6 months, what we'll see, I think we'll continue to see inference be a big use case for centralized and decentralized AI. It's the kind of it's the actual use of any of these models that exist by humans. I think we'll see a push more into augmentation rather than autonomy. I think that'll just continue going on. Like people will build software with models embedded in it, and it won't really even be clear to the user that there is an AI model in it. I've thought this for a long time, and so have many people in the space. But like the chat interface for talking to a machine learning model is like the most naive way of using it possible. There are so many other ways of using it, but it involves basically learning to program with models. And I think that's the next big step for the world is that we stop seeing them as a kind of personified entity, and we start seeing them again as just technology that can be programmed with. And so we'll see just like better and better software appear that uses models underneath. but actually you never chat to it. You don't need the little chat window that says I can ask the model a question like it's a human. Like that doesn't need to exist. It's just better software. It has better error handling. It can deal with like crazy weird data that is unexpected. You don't have to write it to be like fully kind of deterministic from scratch, etc. That being said, when that happens, I think there's a large class of software that does require determinism. It does require verifiability of programs, particularly in the crypto space. This is essential. You cannot write a smart contract if it's not deterministic because you can't execute it across many devices to have the level of trust you need. And so as we start writing more and more software with AI, we start needing a class of AI which is deterministic, verifiable, trustable, auditable, etc. And that happens first in the crypto space, and then it will happen elsewhere in like mission critical systems, safety systems, financial systems, etc. But the clearest, biggest need is in the AI, is in the crypto space.
And I think our time is up. It has been such a great session, and thank you so much, Ben, for joining us. Thank you.
Thank you. Really appreciate it.